Objects and object programming in JavaScript are complex topics. With a lot of information to know, it usually takes days to learn about objects. So the goal of this video is to compact days of training into a few minutes. You will learn about objects, properties, attributes, inheritance, prototype, and constructors. I've summarized all this information into a mind map that you can get by following the link in the description. JavaScript possesses 7 primitive data types: number, string, boolean, null, undefined, symbol, and big int. Everything else are objects. According to the specification, an object is logically a collection of properties. Properties are identified using keys. Think of a key as the name of a property. Property keys are used to get or set props values. A property key value is either a string or a symbol. If you are not familiar with symbols, they represent unique identifiers and they can be used to modify the behavior of JavaScript. If you try to use other data types, they will be converted to strings. Properties are composed of attributes, also referred as flags. The attributes that a property has determine its type. There are 2 types of properties: data properties and accessor properties. In both cases, they have the attributes configurable and enumerable. The configurable flag controls our ability to configure other attributes and our ability to delete properties. The enumerable flag controls the ability to list the property. Data properties are used to store data. They have 2 other attributes: the value attribute, which contains the data we want to store. The data can be of any type. It can be a primitive, an object, or a function. Data props also have the writable flag, which controls the ability to modify the data stored in the value attributes. Data props require both of these attributes. An accessor property associates a key with 1 or 2 accessor functions. The accessor functions are used to store or retrieve a value. First, let's create an empty object. We can add properties to it with object.defineProperty. It takes 3 arguments: the object we want to add a property to, the key of the property, and a property descriptor. A property descriptor is an object that we can use to set the values of the property's attributes. Let's create a data property. Its key will be a string containing the word key. We give it a value, which is a string containing property value. We want to be able to modify its value, so we set the writable flag to true. We want to be able to enumerate it, so we set the enumerable flag to true. And we're going to play a bit with it, so we make it configurable. Now our object contains 1 property. We can read it with object.key, where key is the key of the property, or using the square bracket notation, where you put the name of the key between square brackets. This notation is more powerful because we can use computed key value. We can use any valid expression inside the brackets. For example, we can do something like object k plus e plus y, which will concatenate these different characters into the word key, and we will be able to find the property with the key key. Or we can store the key value in a variable and use it to get the value. The dot notation is, however, more commonly used. Because we set the flag writable to true, we can modify the value like this, or using the square bracket notation like this. If we set writable to false and try to modify the value, its value will not be modified. JavaScript provides multiple ways to traverse an object. I mean by that we have the ability to list the different properties of an object. Object.keys lists all the enumerable keys of an object. Objects.values lists all the enumerable values of an object. Object.entries returns all the enumerable keys and values of an object. We can also use the for in syntax. All these techniques works because we set the enumerable flag to true. But if we set it to false, we can no longer see it anymore. Note that the property still exists and we can still use it. However, if we don't need it anymore, we can delete it. And now we are back with an empty object. Let's now talk about the attribute configurable. When its value is true, we can modify the attributes of the property, and we can delete the property like we just did. Now let's add a new data property that will contain the value of pi, and set false to the flag configurable. When configurable is false, we can't delete the property. Making a property non-configurable is a one-way road. We can't undo it. If we try to modify its attribute, we'll get an error. However, we can still change the writable flag from true to false, but not from false to true. Remember that data properties can store anything. Let's define a data property containing a function. To use it, you just need to add parentheses after the name of the prop. Note that when you don't explicitly define values for the different attributes, they will be false. Also note that you can define several properties at the same time with object.defineProperties. Setting flags with defined property gives us a lot of control on the properties of objects. JavaScript also provides functions to limit access to the whole object. Object.preventExtensions prevents adding new properties to an object. Object.seal prevents adding and removing properties from an object, which is equivalent to setting configurable to false for all properties. Object.freeze prevents adding, removing, and modifying properties from an object, which is equivalent to setting configurable and writable to false for all properties. JavaScript also provides methods to test these situations. Now let's create an accessor property. Accessor's properties, also called setters and getters, are usually added whenever we want to perform some type of processing but still want to use it like a regular data property. As an example, at Computer Bread Industry, we build computers that can act as toasters. Our computers come with a button to control the temperature. The temperature is bound between a minimum and a maximum. To enforce that the value is within this range, we can use a data accessor. Let's create a computer object. Then we need a data property that will contain the true temperature of our computer. We are going to call it _temp_k. The underscore at the beginning of the key is a convention to tell users that they shouldn't access it directly. The key at the end stands for Kelvin, which is the primary unit of temperature in the International System of Units. Whenever you deal with units, it is good practice to add it to the name of whatever uses it. It's an easy way to avoid disasters. Because we don't want our users to access it directly, we will add it by setting the enumerable flag to false. Now let's add our accessor. Let's call it temp_k. Remember that an accessor property has the configurable, enumerable, and one or both of the get and set attributes. Here we are going to define both. The get will contain a function that will return the data property _temp_k. To do so, we need to use the keyword this that refers to the object computer and allows us to read and modify data properties of the object. Here it allows us to access the _temp_k property. Think that this will be replaced by computer, like computer._temp_k. Set will contain a function that will check that the value is in the correct range before modifying the underlying property. Now, if we try to set a value to temp_k, we will get a correct value. We already have covered a lot of things so far. We learned how to create empty objects, how to add data and accessor properties, and how to set their different attributes. We learned how to create objects the hard way, but there's a much easier way to do it that we've actually been using since the beginning of this video. The easy way is by using object initializers, also called object literals. An object initializer is a comma-delimited list of 0 or more pairs of property keys and associated values enclosed in curly braces. Let's define an object that will be stored in a constant named EasyObj. Let's start by adding the unclosing curly braces. We can add a property by specifying its key and its value separated by a colon. Notice that we don't need to enclose the key with quotes. But we can use quotes, simples or double, if we want or need to. Remember that we can also use other types for keys, and they will be converted to strings. Recall that we can store anything in data properties, including functions. This syntax also allows us to define properties using variables. The key will be the name of the variable, and the property will be the value of the variable. We can also define a computed property by writing any valid expression between square brackets. The key value will be the result of the expression. In this case, it will be 4. To define an accessor property, you need to use the keyword get or set in front of the property name, followed by parentheses and the body of the function. As a small tip, note that the last property that you define can be followed by a comma, which makes adding new property easier. Once you created an object with this syntax, you can always add properties with object.defineProperty, or even simpler by using the dot or square bracket notations. When you assign a value to a property that doesn't exist, it will be created. By the way, to check whether or not a property exists, you can use the keyword in. If the key exists in the object, it will return true. Otherwise, it will return false. One more thing. Remember when we talk about listing properties of an object with object.keys, values, entries, and foreign loops? Well, the order in which the properties are listed is a bit uncommon, because it will first start with integers like keys and then use the order of insertion. In this example, the list starts with 1 and 4, and then the keys appear in the order of insertion. If we add a property with a key that is a string but contains an integer, it will appear first. The object initializer syntax is much more compact and is the most used one. However, it is not exactly the same as what we did previously. First, we are not setting the values of the attributes, and by default, they are all true. We can always overwrite their value using object.defineProperty. Second, object initializer allows us to use method definitions, which is a shorter syntax for defining a function property. So instead of defining a function property like this, you can create a method by specifying its name, followed by parentheses and curly braces, and then the body of the function. And then you can use it like a regular function property. However, the method syntax is not entirely equivalent to a normal property with a function as its value. There are differences, but it's a bit too soon to talk about them. The third difference with object.create, and the most important one, is that you can't create truly empty objects. If I try to create an empty object, we can see the presence of a prototype. From the specification, all ordinary objects have an internal slot called prototype. The value of this internal slot is either null or an object and is used for implementing inheritance. Okay, let's try to understand what that means. To make it simple, the specification defines internal slots and methods. Internal slots represent states, while methods describe algorithm. Internal slots and internal methods uses name enclosed in double square brackets. So every time you see double square brackets, it means that it's internal and defined by the specification. They may or may not exist because a JavaScript engine can implement them for their own internal use, but doesn't have to. In any case, they are not accessible from JavaScript. For example, you cannot access o.prototype. The specifications say that all ordinary objects have an internal slot called prototype. In fact, objects can be ordinary or exotic. Ordinary objects must have the default behavior for a set of methods called essential internal method. If an object deviates from the default behavior, then it's exotic. Array, proxy, and string are examples of exotic objects. The spec doesn't say that exotic objects don't have a prototype, but that it can happen. The value of the prototype can be either null or an object. When we use curly braces, it is an object. When we created object with object.create null, the null argument that we used is the value of the prototype. So there, the prototype was null. Finally, the specification tells us that the value of the prototype is used for implementing inheritance. This is why JavaScript is called a prototype-based programming language. Prototype-based programming is a style of object-oriented programming in which behavior reuse, known as inheritance, is performed via a process of reusing existing objects called prototypes. It allows to change inherited behavior at runtime. If you're not familiar with inheritance, you need to know that it comes from the ideas of generalization and specializations. For example, let's say you are building a social media platform where users can post whatever they want. It turns out that some users publish posts that break your term of service, or TOS. To delete the post and ban the users that keep breaking the TOS, you select users that you trust to be moderators. Because moderators are users too, they should get banned if they do something wrong too. But to prevent from one bad moderator getting crazy and starting banning other moderators to take control over the whole platform, you decide to add an admin role for yourself that can't be banned but can promote or demote moderators. In this example, moderators and administrators are both users. They can do whatever a regular user can do. Moderators and administrators are specialized users. And because administrator can do what mods can do, administrators are specialized moderators. The idea of inheritance is that instead of implementing the same functions and properties for each object, you can share them. To do that, JavaScript can store an object inside the prototype internal slot of any object. All objects can have a prototype, which forms a prototype chain. When we try to read a property from an object, but it's missing, JavaScript automatically searches for it in its prototype. If it's not in the prototype, it will look inside the prototype's prototype, and so on until it finds it or reaches the end of the chain. For example, if we define an object with that properties, we can see that its prototype has a toString function property. If we try to use it, JavaScript will not find it inside the object, but will look inside the prototype and find it. Properties directly defined in the object are called onProperties. All the properties are called inherited. And remember when we talk about traversing object properties, it turns out the for-in syntax lists the enumerable own and enumerable inherited properties. Before diving into how to set the prototype, you need to know that objects are stored on the heap. The variable only contains a reference to that object. So if you try to copy this variable in a new one, you only copy the reference, not the object. So if you modify the object with one of the references, the changes will affect all references. This is also why you can define an object as a const and modify its property. The reference is constant, not the object itself. If you want an object to be immutable, you can use object.trace. So now you know that prototype holds a reference to an object, not a copy of it. Like we said earlier, prototype is internal, but there are several ways to interact with it. One of them is by using object.create, where the argument proto will become the prototype of the newly created object. If we try to implement our simple user system, let's first create a user object. Now we can create a moderator object that will use user as its prototype. Note that we can use the second argument of object.create to define properties. Now we have a moderator, we can ban a user, and like a user can publish many posts. Because when we try to access the publish function, it will not find it directly inside moderator, but in its prototype, which is user. The second way you can interact with the internal slot prototype is by using the __proto__ accessor property. However, it's outdated, deprecated, and non-standard. It was first implemented by browsers before being added in the specification as an optional legacy feature. So you should not use it. But because you are probably going to see it in the wild, I will show you how to use it. So we can define an object u1 with the property. Let's create a new object m1 and set u1 as the prototype of m1 using the proto setter. Now we can access the name property of u1 from m1 and we can get the prototype with this. The third way to interact with prototype is by using the methods replacing __proto__, which is object.getPrototypeOf to get the prototype of an object, and object.setPrototypeOf to set the prototype of an object. Before moving on to the last way to set the prototype, let's discuss a few limitations. Even though prototype-based programming allows to change the prototype at runtime, changing the prototype of an object is, by the nature of how modern JavaScript engines optimize property accesses, currently a very slow operation in every browser and JavaScript engine. If you are concerned about performance, you should avoid setting the prototype of an object. Instead, create a new object with the desired prototype using object.create. Another limitation is that prototypes can only be an object or null. Other values are ignored. And there can be only one prototype. Because JavaScript follows the prototype chain until it finds a property or reaches the end of the chain, no circle or reference are allowed. Otherwise, JavaScript will be stuck in a loop and you will get a Stack Overflow error. Now, to talk about the last way to set the prototype, let's discuss about the default prototype of blank objects, defined with curly braces. The default prototype is the object store in object.prototype. We've used object, but what is it? It's a function. Remember when I told you that everything that is not a primitive is an object? Well, functions are objects too. That's why the function object has properties. Object is more than just a function. It's a constructor. It's a function that creates objects. So when you call object, it creates an object, the same as when we create a new object with curly braces. Constructors allows us to create similar objects with the same properties, without having to define them manually every time. Any function can be used as a constructor if we use the new operator. Even though you can use object with that new, the correct syntax is new object. Whenever we call the function with new, the function will be used as a constructor. And new will do the following. It will create a new blank object. Let's call it new instance. It will check whether or not the constructor function has a property called prototype and that it's an object. If that's the case, it will point new instance prototype to the constructor's prototype property. If that's not the case, it will use object.prototype as the prototype of new instance. Then it will execute the constructor function and store its result. It will call the constructor function with the given arguments, binding new instance as the this context, meaning that all references to this in the constructor function will refer to new instance. Finally, if the result returned by the constructor function is an object, then result will be returned. Otherwise, new instance will be returned. This means that if you decide to return an object in your constructor, this object will be returned by a new operator. It also means that if you return anything that is not an object, it will be ignored and new instance will be returned. Now that we know how new works, we can define a constructor to create administrators. As a convention, constructors should start with an uppercase letter. So we decided that admins are not bannable, so we set is bannable to false. An administrator can promote a user into a moderator, or they can demote moderators into users. Now that we have defined our constructor function, we need to look at its prototype property. It turns out that every function has the prototype property. Its default value is an object with a constructor property containing a reference to the function itself. We can modify it by assigning a new object. Here we want our administrators to inherit from moderator. So we set the value of admin.prototype to moderator. Of course, when we assign a new object to admin.prototype, we lose the constructor property. This is usually not a big deal because it's rarely used, but that can happen if, for example, you extend a built-in class. I will probably talk about it in my next video about classes. So if you need the constructor property, you can always add it manually with object.defineProperty. So now we can create an admin using new admin. When we call new admin, a new blank object is created and its prototype is set to admin.prototype, which is a reference to the moderator object. Then the body of the constructor is executed. And finally, the new object is returned. We can see that our object has the properties defined by the constructor and that its prototype is a reference to the moderator object. And the moderator's prototype is the user object. Something important to note is that JavaScript searches for a property inside the prototype chain only when reading properties. When you try to write to a property and it doesn't exist, it will create it inside that object and become an own property. In our example, when we wrote this.isBoundable equal false, it creates a new property isBoundable inside the admin object. The property isBoundable of the user is not modified. Property isBoundable of user is still true, while the property isBoundable of admin is false, because they are different properties. When creating objects with constructors, a common mistake is to forget to use the new keyword. When it happens, the function is executed like a regular function, so no object is created, and we get the value undefined. To help avoid making this mistake, we can enforce the usage of new inside our constructor by checking the value of new.target. In normal function calls, new target is undefined. So inside a constructor, you can check whether or not new.target is undefined. If it's undefined, you can throw an error, or you can call the constructor with new. So now you know how to make constructors that can't be misused. Well, we have come a long way. We learned about objects, properties, their attributes, inheritance, prototype, and constructors. If you would like to help this channel and have all this information and more in one easy, complete cheat sheet, you can grab your copy of this mind map I made by checking the link in the description. Congratulations for completing this video. But we are not done yet. We still need to learn about classes and few other subjects. But we'll do that in the next video on JavaScript classes. So if you enjoyed this video, don't forget to like it and subscribe for more.